In this video, we will talk about array-oriented programming. In particular, we will revisit the notion of vectorization that we spoke about in an earlier video. We will cover how to perform conditional logic with NumPy. We will see how we can do simple statistics with NumPy and also how to sort arrays. In a previous lesson, we spoke about vectorization and said that we can use the term to refer to when performing element-wise operations between arrays of the same size. Vectorization can refer to more operations, for example, when we replace loops with array expressions, as we will see in a moment. In general, vectorization in NumPy refers to how algorithms operate on a set of values at one time instead of on single values at a time. It is a useful and popular practice, as vectorization operations are often significantly faster than their non-vectorized counterparts, especially for large datasets. Let's see how to program using arrays of NumPy and applying the vectorization principle. In particular, let's see how to perform conditional logic in NumPy. We can do so with the use of the where function in NumPy. Assume we have a one-dimensional NumPy array of 10 elements, and we wish to create a second array based on our first array, this array, where the elements that have a value less than 5 here are maintained in our new array, but the elements that have a value greater or equal than 5 are replaced with a value times 10. How can we do so in NumPy in one single line of code? We can use the npwhere function, where we give 3 arguments. And this is the result that we get. So every value that has a value less than 5 has been maintained, and the values that were equal or larger than 5 have been multiplied by 10. So the first argument we give is the condition, that is, wherever an array has a value less than 5 in this particular case. The second argument that we give is what we want to do if the condition is satisfied. So for this particular example, we give again as an argument our initial array, because what we want to do is that if the array elements are less than 5, then we want to maintain the array elements. And then we give a third argument, which tells us what happens if the condition is not satisfied. So for this particular example, we want to replace the values of the array by multiplying the values by 10. In the case that the array values, the initial array values, are greater than 5. The conditional logic we performed using npwhere here and array-oriented programming could be done using standard Python for loop in this fashion. So here I give it as a pseudocode. We could go, for example, over the elements of the array, and for each element, we could check if its value is less than 5. In that case, we would maintain the element, else we would replace it by multiplying the element's value with 10. That would give us a same result. However, we managed to do that with much less code in an array-oriented version, in much more concise and what is more vectorized. The benefits of the use of where for conditional logic in arrays can also be witnessed in this more complicated example. So here we have 3 arrays, array xr, yr, cr. All are one-dimensional arrays of length 5. The first array contains the values 1, 2, 3, 4, 5. The second array contains the values 10, 20, 30, 40, 50. And the third array contains Boolean values, true, false, true, true, false. Now let's assume that we want to create another array called result, where in it we keep the elements of X array if the corresponding element, the element of the same index in the car CR array, is true. Else, wherever here is false, we maintain the element of the Y array. So how can we do that? To achieve this using regular Python, we need to do a for loop. In a compressed way here, we use a for loop, and we use list comprehension, and we also use the zip function that we saw in previous lessons. And we can achieve the logic that we described earlier in one line. It is concise, it is short and elegant, but computationally wise, it is a for loop. Array-oriented programming with NumPy allows us to do the same thing in a much simpler and in a vectorized manner using the where function, in the same fashion we did earlier, by specifying 3 arguments. So the first argument is the car array, which contains our logic based on which our selection of elements for the result array is to happen. The second array is what happens if the condition is true. So therefore here we give the XR array because it is its values that we wish to maintain if the condition holds. It is the values of X array we wish to maintain wherever the condition array is true. And lastly, as a third argument, we specify what happens if the condition is not satisfied, in which case we pass the YR array for our example, as it is its values that we want to maintain whenever the condition is false. So NP-WHERE is a much faster solution than the list comprehension for large arrays, and therefore it is strongly recommended to be preferred. What is more, when we work in multidimensional arrays, list comprehension cannot be used. So your only options there are complicated for loops and many computations, or a concise and elegant single-line command using the NumPy-WHERE function. I know what I would choose. As NumPy is designed for numerical computations, it is only natural that it comes with the capability to perform statistics on arrays in a simple and efficient manner. Assume that we wish to compute the mean value of an array, that is the average value. Here I have a two-dimensional array, I called it R, and I want to compute the average of all the values in the array. For this, I can call the mean function on the array I wish to do the computation on, and that will give me a single value, which is the average value of all the elements in the array. I can also call the mean function of NumPy with the array as an argument. That will give me exactly the same result. Mean without an argument, as we used here, performs the operation on the whole array. It returns the average value of all elements in the array. But what if we wish to compute the average along a particular dimension? We can achieve that by specifying in the parentheses which is the axis along which we want the operation to be performed. So if we wanted, for example, to compute the mean along the column or down the rows, as we say, these expressions are equivalent, we could specify axis 0. Remember that in a previous lesson we said that the column axis is sometimes conventionally given by the number 1. That is a convention. In NumPy, when we want to specify that we want the computation to happen along the column or down the rows, then we have to give the axis value 0. So here we take the mean of the elements on the same column, and the result is added in a new array of one dimension less than the initial array, and in the same index as the index of the column along which the computation was performed. So here, for example, we computed 1 plus 3, that's the elements on the first column, 4 divided by 2, 2, 2 plus 4, 6 divided by 2, 3, 3, and this is the array created with the mean values along the column of the initial array. Similarly, if we want to perform the computation along the row or across the columns, again these expressions are equivalent, we can give as the argument the axis value 1. Again, the result will be an array of dimension 1 less than the initial array where we performed the computation. And here, for example, let's see what happens. We computed the average of the elements of the first row, 1 plus 2, 3 over 2, 1.5, 3 plus 4, 7 over 2, 3.5. There are many other functions in NumPy for doing simple statistics, such as computing the sum of the elements, the standard deviation, or the variance of the cumulative sum of the elements in an array. You can explore the full toolbox in your textbooks or the NumPy documentation online. Another useful thing to do when working with collection of elements is to sort the elements. We have seen how to do this when we work with lists. Let's see how to do it when we work with NumPy array. So here assume that we have created an array with randomly generated numbers. Here's a one-dimensional array of 4 randomly generated numbers, and we wish to sort these numbers. We can simply call the sort method on the array we wish to sort, and as a result we get a sorted array. Also here, if your input array was multidimensional, you could specify the axis along which you want the sorting to happen, along the columns or along the rows, as we did earlier with the mean function. To sum up, vectorization in general terms refers to applying operations or algorithms on values in a set at once. We saw that NumPy offers a lot of methods for performing various functionalities, like the NP-WHERE function for applying logic or other functions for simple statistics. Thanks for watching.